So the first thing I just wanted to point out is that I'm going to be writing the code from the textbook here first. I don't expect it to compile and run right away. I just want to see what happens when we go to type it out for forking and doing an exec VE call like they're showing. So I'll come back in a second with that code. Right now I just have a folder for forking so I can keep my work organized. And we'll have the code from the text. Okay, so let's scrutinize what we've got from the textbook. I've added just a little bit because they're only giving you some of the implementation, like the functions with type prompt and read command. They don't give it to you because we wanted to focus on the fork and exec VE function calls inside our main program. So just to give you a brief look at those, I'll make my text a bit bigger. It'll let me. There we go. Yeah, all I'm doing with type prompt is I'm just going to print it just to demonstrate that you could have other kind of code in there. So I kept it really short. And then read command, I'm just doing similar kind of code when we read in the environment, or sorry, the arguments that you could type when you execute the program. So like the last video demonstration I did for we could have the argc and argv parameters. But we're not going to make use of those here because this code is like an interactive, never-ending loop that's going to ask the user to type something and then read what they type. And then it's going to try to create a copy of itself with fork. And as soon as it does that, remember this is where the code for the copy will begin execution right here. So that the parent code, the original program, it's just going to get back the value of the ID, process ID for the child copy that was created. So it's going to go into the if section for this first block of code and do the wait PID, let the child execute, and it's going to wait for it to finish before it comes back, unless there's some kind of problem. So that's why we have the status variable for, to read back some kind of error code. We might be able to interpret what kind of errors there might have been that happened with the command. Otherwise, the child copy would have the fork call return the value 0. So then it moves on to this second block of code, which is so nicely labeled with a comment. And then it's going to try to replace its own execution with the command that the user typed. I'm not letting it do that. I've just got the generic ls. I'm not doing the memory allocation like you need to do with the assignment. So with the assignment, you're focusing on how do you manage the memory for creating the strings in general like this, rather than creating them like literals the way I've done, which is quite a bit more work. That's why you're focusing on it on your assignment only before we move on to have you write some more code. We'll probably do a fork and then exec VE call. This doesn't have to be some kind of bash command that you're typing on the command line. This could be any program that you want to have it execute. Because remember, the commands you're typing in bash, they're really just pre-compiled programs that are executing when you type those commands. So let's give this one a try. I'm not expecting it to compile. Maybe it will. We'll see. Because there's already issues I can look at when I look at the documentation. For example, for the exec VE, the very last parameter of 0, really we should be putting something else because it's expecting something like params, where it's an array of strings, not like a number like this, which really they're really just using the null value here. So if we're trying to pass an array that's empty, like an array of strings, really what you should be putting is null. So we could talk about that with like the documentation when you look it up, and when we include unit std.h, which is also something else that they're missing from the demonstration code we have to put in. You notice that last parameter, same data type as the argv for the arguments you would pass to correspond with the command you're typing. Remember, that just had to do with the environment variables. They're just key value pairs. For example, like the path or the current working directory for your environment. Let's go back to our virtual hike, and then we'll try to compile. Let's do Control X and I'll save. I just called mine shell.c. Let's see what happens. And we've got all kinds of issues. So the first one is saying initialization of char double pointer from incompatible pointer type char pointer for what it wants for this one. So typically with that, I go in and I'm going to look at this and say, okay, well, I've set it up as my literal, so I really should just cast it as char double pointer array. And we'll see how that handles it. If it fixes the warning, maybe it'll turn into something else. Yeah, and it doesn't like it. So this string value right there, it's probably treating the literal like a char array as well. So every time I'm working with strings, which in C is really just an array of characters, and trying to fit a square peg into a round hole or vice versa. If I'm trying to set up literals like this that are really strange, it's something that you really shouldn't be trying to do on your own. I'm just trying to sit down and do a casting of it to get around in the most straightforward way possible these warnings. But really, when you go to edit your code, you got it like this. You got to be careful. So I do my experimentations with stuff like this, and I just look at what the compiler tells me to see whether I'm allowed to do this kind of cast and these kind of things. So maybe not. Maybe the elements I want would be char, and then it's considered to be more like an array, and it would match better. And then lastly, if it doesn't even let me do that, then I would just break down and try to set it up properly. So I try to see what I can get away with. So literals, I'll get rid of that first and see. And then we've got the read command, too few arguments to function for the read command because I made a call to read command. And let's see what I had in my code because it's got two things it's asking for. Right down here, command and params. Well, so go to nano. I'm just going to pass it command and params. And it's saying our call to fork implicit declaration. And this is because I don't have the library header that we need. So the documentation was saying Unicode, or sorry, not Unicode, Unix standard .h. That's the way I think about the full name for that header file. So we need to add that, otherwise it kind of knows what we would have wanted anyway. And that should take care of those warnings, maybe one left. Implicit declaration of function weight PID. So I think we might even need one more header file for that one. If we look up weight PID for a similar kind of page as this one that we're looking at for Linux manual pages, and we get that pretty quick. The die.net, I don't mind if you're looking at documentation using that. It's got a little bit more of a user-friendly navigation on the left-hand side, and it's mostly the same kind of descriptions. But you got to be careful when you're looking at these different documentations that are available. And it is Linux, and I believe it's mostly the same. But maybe they have exactly the association if they describe that somewhere, maybe on their main page. If we take a look, I'll right click and open that on a separate page. Net projects, a few dozen friends in the US. So it looks like people sharing a bunch of documentation. So it's the Linux man pages, and they just want to reformat them so that they're a little bit nicer to read rather than looking at them on the command line, which we could do. You've got the command where we type man space and then followed by the name of whatever the command is you're trying to work with. But it looks like they also have the descriptions for the different system calls that we can make on Linux that are available. And this is one of the system calls that we're making with fork and with weight PID. So let's just use it. I don't mind if it's the different one. I tend to use more often the first kind that we were looking at, the one that doesn't have the red navigation on the left-hand side. So if you got weight PID, it's coming out of we need the types.h header file and the weight.h header file. And then we can make use of these. And now it does have a little bit of further description, more specific data types for the parameters. You can get away very often just using things like int for a lot of these, or if you go to look up those actual types to see exactly what they're defined as. Oh, that's weird. They don't even let you take a look at that. Let's go look that up. Types.h to see where we can get documentation for that. Opengroup.org. This one's for IEEE standards for their data types. I would trust IEEE for a standard when they're describing the data types they're supported when they're talking about system /types.h header file. So let's take a look. If we look at the first one, we've got ID type _t. And we're not getting a search hit for that on this section. So they might even then, do you have ID _t? And they've got that there for different, and I would consider that to just be an integer number. But I was hoping we could get a little bit of a better description of exactly where they define them. So we might even need to look somewhere else if we wanted to see the declaration in terms of what the header file actually looks like inside. You could get at it. So maybe not the greatest you know what's in there, but it's not describing it exactly what those data types were defined to be. A lot of times it's just a repurposing of the integer data type. So let's take a look at types.h for POSIX standard. Yeah, and you get a little bit more with this. So let's take a look a little bit closer. So that first one we're looking at, ID type _. Even that one's not in here. So I would expect it to then be in the other header file. So let's do that one. You just got to do your best trying to look up where you're going to find it. So they've got descriptions on different places as well for this. You've got some for Ubuntu, which you might be able to do if you've got the Linux version of Ubuntu that you're using. So you might want to prefer that documentation. We've got IBM.com, which is saying, okay, they got the POSIX description. So I might want to look at that one because many will support the POSIX standard. But it's not really giving us a whole lot other than the function calls. So I'm kind of surprised by that. I don't really want to look at Stack Overflow that much for looking up documentation. Instead, they're going to be looking at the problems they're having with those header files. And I don't necessarily need to read something like that. So this is really good from sites.uc Louvain. So same domain as the types.h we found. And it's giving like an actual C code, what the header file actually looks like, which is really nice. That's what I want to get at. So I can see the exact defined statements they're using and maybe some of the other declarations of their types. So let's do look up in here for that. Oh, there it is right there, ID type underscore T. So it's actually an enum. And you could have different configurations for how you want to use our function call. So wait for any child, wait for specified process, or wait for members of a process group. So it's changing the functionality of our wait PID function call. Or the wait ID function. So let's go back to the description here. If we get, okay, I'm looking at wait ID, but we want to use wait PID. Okay, so if you're curious about how you're navigating and figuring out how to use some of these functions that we have available in the system, because we don't have time to cover all of them, and you're curious and you want to know, maybe you've got the functionality that you'd like to use in a better way with some of these other functions that are listed in the header files. There's nothing stopping you from going in to try to figure out how those work. And they might be exactly what you need. So that's how I do it. I go in, I look at the documentation, I actually read to try to figure out how I'm going to use these functions. And the more that you look up in the documentation, try to read and figure out, the better you get at figuring it out quickly. So the first struggle that you'll have is, what are the kind of pages where you need to look at to read that documentation? So I'm looking at something like die.net that's got the red navigation on the left. It's giving you the Linux man pages, which is nice, a little bit nice, more nicely formatted. And then once you see those function calls that are available that you can look up directly, you can see what headers they belong to. And maybe we need some of the other headers for the data types that they're expecting for the parameters. And we could even read more about those headers specifically if we want to look at the code. This is what's getting replaced when we do include. It's going to give us all these different data types that we could work with. And you can read a little bit with some of the comments they have with it. But of course, all of that, I'm not going to go in and try to memorize everything or try to read it all. I'm going to try to do Control F, and I'm going to try to get at exactly what I'm looking for. So ID type underscore H. I didn't find it in types.h. So I'm like, oh, well, I'm not going to give up. I'm just going to look at the other header file. Okay, and there it is. It's in that one. And all it is just an enum, and it's got 3 different constants where I don't have to worry about what the number means, 0, 1, or 2. I just get to read the enum name that they gave these, so it gives it a little bit more meaning. What does it mean? Well, it gives you a little bit of a description in the comment beside it in the header file. So this is really useful to be able to know where you need to look if you're going to figure out beyond the textbook what you're going to program in C. So I know that sounds like a lot right now, but this is actually the way you want to sit down and do your work. And think about everything you're losing out on if you just grab some code from somewhere else. You lose the ability to figure out how to write your own code that works with Linux and all of the things that are available there. And if you're grabbing code from somewhere else, you don't understand it, you shouldn't be using it because you don't really know exactly what it's doing. You could run that code, and for all you know, when you go to execute it, it's going to delete every single file on your computer because that's absolutely possible. So I would highly recommend that you learn how to read the documentation, go figure out for yourself how to write the code. Okay, and the next thing we would want from the wait PID is we just wanted to look at that last parameter, and then I think we'll finish up here pretty quick when we actually go to execute. Let's see, wait PID, it just says integer options. So in that case, I really would just place the value 0 because I'm not making use of the options for this function call right now. So we're not getting into more detail with using wait PID. The only thing it's doing when you read the description is it says that they're just used to wait for the state changes in the child when you're spawning another child process. So we're going to use this program to create and execute another program for us. And so we can use this function called to then wait for that other program. So when does it return? It's going to be when we have a state change is considered to be, and then they have the child terminated, which is pretty much how we're using it here. And then if you want more detail, you can read it on your own later. So we have the wait PID the way we want it, but we just need to include another header file because it's saying down with the second time we try to compile, we still need the types header file. Okay. Let's put it up above std. So we've got sys / types.h, and they wanted the other one sys / wait.h. I think those were the two. Yeah. Okay, let's save that, compile one more time, and then no more errors, no more compiler errors, no more warnings. So we do want to try to write our code to get rid of all the warnings as well. We could have tried to execute the code anyway, but you really should be writing your code so that there's no warnings either. And you can be even more strict about that if you compile your code with -w and the option all. And that will give you more warnings to try to check against bad programming habits. Now, it's kind of a misnomer because the option all, when you're doing a compiler check for this, is not actually going to check everything. There are yet more options that you can set when you compile. And you could be even more strict if you want to. So just keep in mind that this is generally an option that they tend to use all the time when you're sitting down and doing development to just make sure you've got good coding practices while you're writing your source code files. I'm not expecting this program to do a whole lot. Yeah, it's just going to keep going forever. So I hit Control-C. And it's just printing my parameters that were passed -LA over and over again because I had that in a loop. So let's go in and just observe the code one more time to see what we had written. At the very beginning, I would have expected it to print my prompt and then do the read command and then print off my params. while they're not null. So I think it's probably not reading even this memory properly. So I'm kind of cheating a little bit by setting up my variables using local memory rather than dynamically allocating memory like we should be doing. So I'm trying to just set up the code as quickly as it can so that it can execute. And I'm not concerned on focusing, having my array of strings for params set up dynamically. So I'm just avoiding spending time on that right now so we can focus on looking at the fork and then the exec VE. So what I'll do next, because I don't really need it to print over and over again like this, I'm just going to comment out the while loop for the parameters. Maybe we'll just have it do printf read command. Let's see, it should do that the one time and then it's forking. And I don't think we really need it to loop over and over again because I'm not writing this code to do a full terminal for me, where I'm going to ask the user to type something in every time it loops and then execute that as a separate child process. Exec VE for the command params, we're going to see whether that will actually execute, and it's going to do ls-la for us. I want to check whether it's actually going to execute or not. If it doesn't, it means there's probably some kind of error and I didn't set up the memory for passing the parameters quite properly. So the next thing we would look at in documentation would be exec VE to see how we're using it. So we'll give it one run after we compile. We've got an unused variable. Here I will just demonstrate that you can still execute your code even with warnings, but you really should deal with the warnings as well. So it printed the function for executing my prompt, which is just printing the one statement. And then it's executing the code to just demonstrate that we can print the string ls that was passed to the function read command. But then it's not even executing the ls command, because what I should see is ls-la, and I should see the files in this current directory. So let's next then take a look at documentation for exec VE. And we've got our Linux manual page for this. It wants const char path name, and that's just doing ls on its own. You'll notice that I haven't passed the environment variables at all. So it probably even wants like the full path to the execution for the command ls in order to execute it properly, which we'll give that a try next. And then the arguments that go with it, perhaps we need the arguments to also include the name of the program that we're trying to run as well. So maybe when we read down here, we'll see argv is an array of pointers to strings past the new program as its command line arguments. By convention, the first of these strings, argv0, so it's just like when we did the demo for reading from the command line, should contain the file name associated with the file being executed. Okay, let's try that first then. So when I go into my code, we go down to my list of parameters. The first one should actually be ls. Let's save that and then compile and give it another try. It's still not doing it. So then the next thing I would try is likely, I think it would likely want the exact location for ls. So the first thing I would try would be bin /ls. I'm going to guess that it's in that location on my system for Linux. So Linux tends to have the same kind of structure underneath the main root directory. as you commonly see across many different kinds of distributions and similar to Unix. So a lot of them will have this bin folder that also includes a lot of the commands that would be executed that you'd normally type. Now, I might be wrong about that. There might be another one for myself specifically as a user. And that means I probably also have to update. Yeah, I should probably go in and update exactly the command we're trying to type as well. And have both of them match like that. And then failing that, I think I would probably have to break down and look up more in the documentation, do a bit more reading. And there we go. So it's executing our command bin ls, and I see the output for that command. So I know that the child process that we spawned, that executed successfully, because that's what was executing our ls command, not our parent program. So I think this is a good demonstration of just seeing how fork and exec VE work hand in hand with each other like this. You're writing one program that will spawn another one for you. We'll do quite a bit more this semester with this. We're definitely going to do it on some kind of assignment at some point. And we give you a chance to see how you can write code that's going to control your system to manage more processes rather than having to do it by hand on the command line yourself. So it's really good to automate that kind of thing.